So today we are doing dilations. Dilations make something what? Does anybody know what if you dilate something, it makes it bigger or smaller? It makes it bigger or smaller, okay? When you dilate with the center at the origin, it's really simple. It's just gonna be you're multiplying. So here your scale factor is 2. So we're just gonna be multiplying everything by 2 if you're doing it with respect to the origin, okay? So what is my point G? What are the coordinates of it? 2, 1. And to get to G prime, I'm gonna multiply by 2. I'm gonna multiply by 2. So 2 times 2 is 4, and 1 times 2 is 2. So G prime is gonna be at 4, 2, okay? What are the coordinates of H?
4, 1.
I think it's 5, 1. Okay, 5, 1. And what do you have to do with those coordinates? You have to multiply them by 2. So H prime would be what? 10, 2. 10, 2. Okay. What are the coordinates of I? 5, 5. And what do I need to do with those? Multiply by 2. So I prime is 10, 10. Okay. All right, so if your center is at the origin, all you have to do is multiply. All right. Number 2, find the scale factor. Find the scale factor. Let's look at point E. It's kind of hard to see the numbers, but 1, 2, 3, 4, 5, 6. Do we think E is at 6 up? Okay, so let's say E is at 0, 6. E is at 0, 6. And what do we think E prime is at? 0, 3. Okay? To go from E to E prime, did it get bigger or smaller? It got smaller, so the answer has to be a fraction. If you get smaller, your answer is going to have to be a fraction to get smaller. Okay? What can I multiply 6 by to get 3? A half, okay? So your scale factor is a half. 6 times a half gives you 3, okay? Another way you can find that is you would do E prime over E, E prime over E, so 3 over 6. 3 over 6 gives you 1/2, okay? Questions? Okay, number 2, give the coordinates of the image J, K, L, M after a dilation with its center at the origin and a scale factor of 1/3. What's something that's important that I should circle? Scale factor of 1/3, so that's what I'm going to be multiplying by. And another thing that's important is the center is at the origin. The center is at the origin, okay? All right, let's start with J. We'll go in alphabetical order. What are the coordinates of J? 6 to the left, so that's -6, and then up 1, 2, 3, 4, 5, 6. Okay, and I need to take both of those numbers and multiply by 1/3. Multiply by 1/3. So J prime, what's -6 times 1/3? -2. You may use your calculator, and 6 times 1/3 is +2. +2. Okay. All right, let's do K next. What are the coordinates of K? -3, +6. Okay. So to get K prime, I multiply both of those numbers by what? 1/3. You multiply by the scale factor, so multiply by 1/3. So it becomes -1, 2. -1, 2. Okay. All right, J, K, L. What are the coordinates of L? 0, 3. It's on the Y axis, so the 3 has to be in the Y position. All right, we're multiplying those by 1/3, and what will that give us? 0, 1. Okay. And what are the coordinates of M? negative 6, 0. It's on the x-axis. It's on the x, so negative 6 has to be in the x spot. All right, what do you get for m prime? Negative 2, 0. You multiply these two numbers by 1/3. Okay. Questions? All right, triangle A prime, B prime, C prime is the image of triangle ABC under a dilation such that A prime, B prime equals 3 times AB. Triangles ABC and A prime, B prime, C prime are, what's something that I should circle in that problem? It's a dilation, okay? What's it a dilation of? What's the scale factor? 3. It's right there. Your scale factor is 3, okay? All right, if I am multiplying something by 3, it's going to make it bigger. It's going to make it bigger. So are my two triangles, will they be congruent? No, they will not be congruent. So I can mark out the first answer. Answer 3 also says they are congruent, okay? Similar means they're going to have the same what? Shape. Will they still keep the same shape? Yes, they will. So they will be similar but not congruent. Okay, similar means they'll have the same shape. Okay. Number 4, what is the rule for D sub 3 x comma y with respect to the origin? What do you think that D stands for? Dilation, so write that down. The D stands for dilation. What do you think the 3 stands for? So it's a dilation with a scale factor of 3. That's not your answer. I just want to make sure you understand the notation. The answer wanted a rule. So the rules are what we've been working with. So x comma y transforms to, very good, 3 times x, 3 times y. You would multiply both your answers by 3. So that's the rule. Okay. Okay, number 5, under a dilation with respect to the origin, the image of P, negative 15, 6 is P prime, negative 5, 2. What is the scale factor? So which one is your original, P or P prime? P. So this is your original. That's what you started with first. And then you went to this one. So first of all, did it get smaller or bigger? It got smaller, so your answer has to be a fraction. So automatically you know it's this. Let's talk about if they would have had more than one answer that was a fraction. You would have taken P prime, which is 2. Well, actually, you can take the x or the y coordinate. So let me do the x coordinate. So you take negative 5, divide it by the x coordinate of this one. Negative 5 divided by negative 15 is 1/3. So that's where you would get that from. So this would be P prime. So you would do your prime on top divided by your P if you needed help finding that out. Okay. All right, number 6, the image of point A after a dilation of 3 with respect to the origin is 6, 15. What was the original location of point A? So am I going forwards or backwards? I'm going backwards, okay? So I know you get 6, 15 after you multiply by what? Okay, so you're multiplying by 3. Your dilation is 3, so you're multiplying by 3. So if you look at each of your answer choices, which answer choice, when you multiply by 3, gives you 6, 15? 2, 5, the first one, 2, 5. Okay. Number 7, under a dilation where the center of dilation is the origin, the image of A, negative 2, negative 3 is A prime, negative 6, negative 9. What are the coordinates of B prime, the image of B, 4, 0 under the same dilation? Okay. All right, so you have A and you have A prime. Let me just remind you how to do it by hand if you're not sure how to do it. Some of y'all know how to do it in your head, but if you want to know the rule that always works, you would do A prime divided by A, and I'll do the x coordinates for this one. So A prime is negative 6 divided by negative 2. What's negative 6 divided by negative 2? 3. So 3 is my what? my scale factor. 3 is my scale factor. So I am multiplying by 3. Multiplying by 3. So I need to take 4, 0 and do what with it? Which gives you 12, 0. Gives you 12, 0. Okay. And number 8, on the set of axes below, Jeff drew rectangle ABCD. He will transform the rectangle by using the translation x plus 2, y plus 1, and will reflect the rectangle over the x-axis. What will be the area of the rectangle after these transformations? Okay, so guys, let's think for a minute before we do any work. This right here, what does this x plus 2, y plus 1 mean to do with it? Okay, that's what it does mean. What else does it mean as far as moving it around? What does the plus 2 mean you're doing it? 2 to the right and 1 up. Will that change the size or shape of this rectangle? No, you're just moving it, okay? What about when you reflect it over the x-axis? Will it change the size of the rectangle? No, okay? So I don't actually have to do any of this work. I can just find the area of the original. I can just find the area of the original because this and this is not going to change the size of it, okay? All right, so how do you find the area of a rectangle? Length times width, okay? What is the length of this rectangle? 7, you can count along the bottom. 7, what is the width? 4, you can count right here. 7 times 4 is 28, okay? So what will be the area after the transformations? Yes, it'll stay exactly 28, okay? All right, here's my question. What kind of transformation would have changed the area of the rectangle? Very good, a dilation. A dilation would have made the area either larger or smaller.